All right, let's dive right into this explainer on how to stop renting compute power and build your very own private, highly automated AI second brain. Look, if you are tired of watching your data and your dollars flow out to remote servers just to run some basic automations, you are in the exact right place. We're going to explore how one developer completely replaced a heavy, expensive cloud setup with a lightning-fast local network running entirely on Apple Silicon.
$340. That is the actual shocking monthly cost most developers are burning right now on public API tokens and cloud virtual machines for their AI workflows. The source author of this setup looked closely at their expenses and realized they were paying 7 different companies just for the privilege of using AI. I mean, they had line items in their credit card statement that they genuinely could not even identify.
To get to the bottom of this, the author did something really smart. They opened a note and wrote down the absolute last time they actually used every single one of those subscriptions for a real piece of work. And the realization was totally stunning. These tools had basically sat unused for over a month. So they immediately canceled 6 of them. Just like that, they saved $140 a month instantly, without changing a single thing in their workflow. The remaining $200 was going to tools like Claude Pro and Cursor, purely because somewhere on the internet, a GPU was running a model they felt they couldn't run themselves. But as this explainer proves, in 2026, you absolutely no longer need a remote GPU to run a powerful model.
Here is how we're going to unpack this whole system today. 1. The AI subscription trap. 2. A 4-layer architecture. 3. The 5-tier memory engine. 4. Local hardware and setup. 5. Case study, bulk ingestion, and finally, 6. The ultimate ROI. Let's get to it.
Starting things off with Section 1, the AI subscription trap, and why we really need to rethink our traditional workflows.
You know, a passive system simply wastes your time and your money. Just highlighting notes? It basically gives you this illusion of learning, but science actually shows you retain almost none of it. To really retrieve and encode information, active recall is absolutely required. And this is exactly why the author spent a weekend pricing out every single local option that works, moving entirely away from those passive cloud subscriptions. We have to link active execution, semantic synthesis, and durable storage, and we need it all operating at 0 token cost.
Which brings us to Section 2, a 4-layer architecture for dividing up the labor.
Instead of forcing one single model to handle absolutely everything, because standard vector search often fails on complex relationships, the labor is cleverly divided across a complete architectural matrix. You've got an active execution layer running scripts and commands, a passive semantic layer where NotebookLM digests massive bulk documents into clean summaries, a durable memory layer using Obsidian to store your structured files locally, and finally, an ambient capture layer utilizing wearable hardware like OMI to log your conversations. Obsidian is where your secure vault lives, but NotebookLM is where the heavy processing happens. Together, they form this perfectly unified brain that neither tool could ever deliver on its own.
Moving right along to Section 3, the 5-tier memory engine, and how we actually stop context bloat.
We have to address the major problem of token waste that causes standard agents to completely degrade after just 10 turns. By mathematically compressing historical logs into a lightweight SQLite database, we keep the system's VRAM completely free and the agent's execution lightning fast. The context window size at any given turn is tightly managed. It combines your base prompt, your compressed historical logs, and a user profile that is strictly capped at 1,300 tokens.
Let's actually step through these 5 distinct memory tiers that make this compression possible. We are distributing data flawlessly here based on stability and frequency. Level 1 is your hot local memory for instant preferences. Level 2 is your cross-session database log for superfast searches. Level 3 uses dynamic buffers for active context. Level 4 acts as your durable, permanent knowledge base right on your desk. And Level 5 captures that ambient background context from your daily audio logs. This tiered structure is a total game changer because it protects the model's focus during those incredibly long execution loops.
This quote right here really captures the absolute core of our explainer. Memory is what transforms a simple, forgetful chatbot into a fully autonomous workspace. It is literally the difference between starting from scratch every single time you type a prompt and having an assistant that truly knows your entire operational history.
All right, Section 4, local hardware and setup. Let's talk about powering this engine without melting your computer.
The contrast between these two setups clearly explains why this architecture is so revolutionary. On standard PCs, models are forced to bottleneck, because they have to constantly copy data back and forth between system RAM and a separate, discrete GPU VRAM. But with Apple Silicon's unified memory architecture, the CPU and GPU share a single memory pool. This is huge. It allows a Mac Mini M4 to host massive models, like a 32 billion parameter Qwen Coder model running completely offline, completely headlessly, and consuming only 10 to 30 watts. It keeps your fan dead silent and your electricity bill under $5 a month.
So the absolutely crucial point here is that by installing these base dependencies and establishing automated pathways, you entirely remove those manual, tedious copy-paste routines. With memory bandwidth hitting anywhere from 120 up to 273 gigabytes per second, your prompt prefill is accelerated immensely. You're using tools like Llama to run local APIs and specific plugins to bridge your agents directly into your Obsidian Vault or push files automatically to Notebook LM. And best of all, keeping everything routed through your local host means your data is completely safe from prompt injection attacks.
Let's put this into practice with Section 5, a tangible case study on bulk ingestion.
Imagine trying to ingest the entire Andrew Huberman podcast catalog. To do this manually would take literally hundreds of hours of listening, typing, and formatting. But with our local pipeline, the whole setup is completed in mere minutes. The agent parallel downloads 300 raw transcripts using a custom script, formats them, and pushes them seamlessly into Notebook LM. Then, you simply ask the engine for clear health protocols. It returns beautifully synthesized outputs with exact citations, clustering videos around topics like sleep protocols and memory retention, using wiki brackets right in Obsidian.
And this brilliantly illustrates how the system isn't just a dusty storage vault. It acts as a private content factory running completely on your local machine. From a single source batch, Notebook LM can generate mind maps, study guides, or audio overviews. Then, the Hermes agent pulls those assets down, cross-references them against your personal voice guidelines to maintain your exact brand tone, and spits out a finished corporate newsletter directly to your local drive.
Of course, an autonomous system this powerful needs some structure, right? By adhering to this strictly timed maintenance and ambient context schedule, you stay in total control of the automated execution without ever having to do manual document entry. Your morning stand-up script triggers every day at 9 a.m. to read your calendar and yesterday's wearable logs. Then you have weekly and monthly audits to clear out orphan notes and ensure your directories don't hit limits that might crash or throttle your local processor.
Finally, Section 6, the ultimate ROI. Let's look at the undeniable financial math here. To put this into perspective, for the price of maybe one fancy cup of coffee a month in electricity, you completely replace a massive, bloated cloud bill. The author went from a $340 monthly subscription drain down to zero. Even when you factor in the cost of buying a brand new Mac Mini M4, the year-one savings are over $3,400. By year 2, you are saving over $4,000 annually. You are literally funding a 24/7 B2B research pipeline with absolute privacy and zero API limits.
Which leads us with one incredibly important question about the future of your own workflow. Now that you've seen the architecture, the hardware, and the undeniable financial logic, it's time to reevaluate your setup. Are you going to keep paying monthly rents to access fragmented pieces of intelligence? Or are you ready to stop renting your compute power and invest in building a powerful, permanent, local second brain?